Hey, everybody, and welcome to this episode of the History from the Homestead podcast. I am your host, Thomas Carroll, and joining me today is William Oldani and Jerry Miller, and we're going to be talking about the world's largest dragline. So, gentlemen, welcome.
Thanks for having us.
Sure. So, I guess we agreed ahead of time to start with you, Jerry. Just give a short background about yourself and your history with mining equipment.
Okay, well, I can tell you that I served an apprenticeship at Bucyrus-Erie Company. I started in February of 1966, so that makes me an old timer now. I'm probably one of the last people that's still around that was able to actually put his hands on the parts for Big Muskie when it went through the shop. I was just an apprentice, so I was not one of those guys that was doing all the thinking and the planning and doing the journeyman's work, but I was working with the journeyman, doing basically all the grunt work for them. But I feel privileged that I actually did have a small part in building that machine in the factory.
Well, you do have, and you have a small part in a Guinness Book of World Record as well.
Yeah, that's nice to know. I can tell you that we spent a lot of time in those old days there, getting real dirty and cleaning parts and doing a lot of grinding and dressing and doing lots of heavy lifting with big cranes and putting large machinery together. And it's been a long, long time, so I can't remember a lot of specifics, but I do remember working on some of those components of that machine and loading those big components onto flat cars. I believe somewhere between 300 and 400 shipments of that machine were on railroad cars. Because you had so many big, heavy sections that had to get shipped out of there.
Wow.
And we worked in a smaller shop than what was available to us in modern times. We didn't have the big weld shop that they currently have now under Caterpillar. Our weld shop was much smaller. So everything had to be built in more confined spaces back then. And back then, there were not a lot of rules about safety. So you could climb in stuff, you could climb on stuff, you could do all kinds of funny things that we wouldn't be allowed to do today. And you were expected to just keep working. And we were all on an incentive system. So you had to work fast and you had to work hard. And we were working long days. I can tell you that a 12-hour day back in the 60s was pretty much a standard weekday. We had normally 12-hour shifts during the week and 8 hours on Saturday, and then usually 6 or 8 hours on Sunday and a lot of weekends. I remember a time in, I believe it was 1969, Big Muskie was probably finishing up at that time, but I remember where we had unlimited overtime in the assembly area posted, big letters posted up on a wall that were hand painted, said you could work any hours you wanted to work as long as you started at your regular start time. So that's how we worked in the factory back then. It was heavy work, big wrenches, big tools, lots of climbing, lots of working on concrete all day on your feet, working underneath machinery. And we built a lot of big machinery back then. A Big Muskie had 10 swings, for example. All of those had to be assembled and they had to be tested. So that's a lot of big press work and bearing work. The hoist and drag machinery, we built the intermediate shafts with the gears. We did all of that gearing, hand dressed every single piece of it. All that gearing had to be hand dressed. They were MOG cut and a MOG gear cutter, generation cut, and all of those gears were brought down to assembly in machined form, but they didn't have all the chamfers and everything done like you would expect probably today. So every single tooth on every part of that machine had to have the uh, chamfers put on manually. So each face where it meets the face and the root and the tip, and it all had to be hand dressed all the way around each and every gear on both sides. So that was part of the apprentice's job, was to do all that hand dressing. And what we would do is we would set the intermediate gears, for example, for the hoist and drag. We'd set those on plywood on end on the floor, so it actually was sitting on the teeth. And then we would dress and then roll those by hand, and dress and roll and dress and roll till we got all the way around 360 degrees around that gear, and then clean it all off. And then the journeyman would come along and he would put the shaft and key. All of those were keyed. They key that gear to that shaft and get it started in there, and then pick that up with two hooks on the crane and put it into our 150-ton horizontal press and press that gear and shaft together. So that had to be done at every single intermediate gear assembly. All of those were done like that. So that's the type of work that we were used to doing every day in that shop, handling that type of machinery. And then once we got the shafts and gears pressed together, well, then you had to put the bearings on, the bearing retainers. So that was all hot work in an oven. Usually we'd have bearing ovens. In some cases, we actually had a big enough freezer that we could freeze some of the shafts and then stick them into the bore of the gear that way by freezing the shaft. So we've done it both ways. But I remember doing a lot of that. I can also remember working a little bit on the propel hydraulic cylinders. You know, you got those big cylinders that are the push cylinders. Those were 27 inches in diameter, if I remember right. Leo would probably know more about it than I do. He's expert on all the drawings, but I think the lift cylinders were 58-inch diameter, and I think the push cylinders were 27-inch diameter. And I was a skinny little dude. I was only in my teens yet when I started my apprenticeship. So I was a guy that they picked up, and we set those push cylinder housings up on horses, and the two guys picked me up and pushed me into the cylinder with the grinder ahead of me and a flashlight ahead of me, because my shoulders would just fit into that cylinder. So I had no way of moving in there by my own power. So they put a broom up against me from the backside and pushed me in with a broom, but they had a rope tied around my ankle, so that when I got done with my grinding and cleaning operation down at the end of that cylinder, they could pull me out. So I had to do all four of those push cylinders in that method. That would not be allowed, of course, today. But that's how we worked back then. And I still remember that particular job, because that was one of those jobs that really nobody else could do but a skinny little guy like me at the time.
See, Bill, and he said that he didn't have any stories to talk about before when I talked to him. Bill, let's put you in the hot seat then real quick. Give us your background in mining.
Well, I'll take you back to the beginning. 1967, I was in the 6th grade, and we moved to Pennsylvania. And where we went to Hazleton, Pennsylvania, and the Jetto Mining was located right adjacent to where we were staying. I heard a lot of noise up there. I didn't know anything about mining, and I climbed up the mountain and went around to the back of the pit, and I saw an 8700 dragline. Now this was back in, it was built in 63, 64, and at the time it was the largest dragline in the world. Marion built it, but I didn't even know what it was, and I got bit. I'm telling you, whatever that thing was, that's what I'm going to do. So in 1975, I went to the Colorado School of Mines. I got a mining engineering degree. I left there and started working for Southwestern Illinois Coal Corp, where the Marion 6360 shovel was located, which it also was the largest stripping shovel ever built. It rocked the scales at 30 million pounds. And during my period at Captain Mine, I was asked to develop a bucket wheel that would accompany the 6360 shovel. A bucket wheel is a machine that roughly takes the unconsolidated material from one side of the pit to the other. And the reach on this machine was 716 feet. One of Jerry's cohorts, Carl
Gilmore.
Carl Gilmore,
Yep.
was the one that actually took my work, and they created the machine, which ended up being built. And I'm telling you, my entire career was involved around these huge machines. I saw the Big Muskie in 1981. It was down for the period we were there that day, but I was able to get on the machine and see it. I made a line drawing of Muskie back in 1979 when I was still at the Colorado School of Mines. And I sent it to AEP where the Muskie was, and they had it. And now I think the line drawing is actually at the Bucyrus Museum in South Milwaukee.
It is.
But
It's on our wall, and we proudly display that.
I am absolutely just amazed by that machine. And when I got to meet Jerry and his other workers or pals there at BE, I considered it a real honor, and it still is to me. These guys are the heroes of the mining industry. Muskie, the story of Muskie really can't be appreciated for what it's really worth, is because when you consider these guys took something that didn't exist and in a year and a half put 28 million pounds of steel on the ground that could swing a 220-yard bucket and leave it 300 feet away. Just is just mind-blowing to me. And I asked Jerry the first time I met him, I said, did you work on the boom at all? He said, I had some input. I said, how in the world did you guys create that boom on that machine? I said, I've never seen anything so solid in all my life. And he says, well, if we didn't think it had enough steel, we put more in it. And I'll never forget that. When they dropped that boom in, I think it was 99, they came in and shot the back legs and let the boom fall. That boom hardly flexed when it hit the ground. It was so solid. But basically, that's my input on it. And I like drawing 3D digital models of all the large excavators. And that's actually how I got to meet Jerry, because I did Big Muskie and I did a lot of the other machines that they created, the 3270s, the 3850s. Just great group of people.
Yeah. And that brings us to now the star of our show. You've heard us talking about Big Muskie, which it was the largest drag line in the world. Still is to this day, and as far as I'm concerned, it probably will be, forever. I don't think they're ever going to build another one that big, but
Oh, they never
maybe,
will.
yeah, maybe for some who don't know, which, Bill, we have your 3D renderings up there, which are amazing looking. We'll kind of try to, in layman's terms, we'll work through what a drag line is. I grew up around it, and probably most people in the Pennsylvania area has, but for anybody that hasn't, we could kind of try to our best to describe what a drag line actually is.
No, I'm sorry, did you?
Oh, no, you're good. I had to take a quick drink. I'm sorry.
Oh.
Which, we're talking about mining, which drag lines are a mining machine, but it's almost as simple as you have your bucket, you have 1, 2, or more hoist cables, drag cables, and you more or less just lower the bucket into the pit and drag it in. Why they call it a drag line. Drag it in, fill it with dirt, and dump it wherever you need to dump it at to expose the coal seam.
I can add just a little. I know Wheel is more of an expert on the design of this machine than I am, but I can say that a drag line sits up on top of the bank, and it's designed to reach down as much as close to 200 feet below the level that it's standing at, and just pull out big quantities of material and then move them to another location to open or expose, in this case, a coal seam, so that you could then come in with your smaller machines, and they're not small either, but your shovels and trucks, and load out the ore that you're actually going after. So This coal ore is usually well below the surface of the ground when you start. It could be 100 feet down, it could be 150 feet down, but whatever it is, you need a big drag line like Big Muskie or other to remove all of the overburden, all the dirt that you don't want, and move it out of the way so that you can get at the ore that you're after. And that's the effectiveness of such a big machine that can reach way down as much as 200 feet and pull this material up, turn, and then stack it, not really always behind it, but alongside of it someplace, and actually stack it up pretty high. I think it can reach up another 150 or 200 feet above the ground level. So you might be lifting it as much as 300 or 400 feet in total, and you're moving a tremendous amount of earth. I've seen statements, Wikipedia made a statement about the earth in that bucket on Big Muskie. And by calculation, with the ore that they're talking, with the overburden they're talking about, that dirt alone weighed 650,000 pounds in that bucket. And if you add to that the weight of the bucket, we know by shipping weight that that bucket and rigging weighed 460,000 pounds. So you're picking up well in excess of 1 million pounds and moving that somewhere between 300 to 400 feet vertically, and then and dumping it alongside that machine. That's a tremendous amount of energy and tremendous amount of load that you're moving when you're operating a machine like this.
Yeah, and which Bill, you have the perfect picture up there to show the size of how this was. We're like you said, we're talking at 28,000 tons of steel. Yes, you heard that right. 28,000 tons is what that weighed. And it was, let's see, what, 200 and you got there 222 foot tall to the top of the gantry and 239 feet tall to the top of the boom. I mean, you think about that. That's
to be a little more correct, we list the weight of the machine at 27 million pounds. So that's what we have on our publication. It may have been heavier than that, but that's what we use as a number.
Yeah, and that's just you almost can't wrap your head around that number. It's just wild.
No, you can't. But we have a display at our museum. We have this model of this machine in HO scale, 1/87th, and of course we're able to get people in cars, trucks, the same scale, and have them placed alongside of this machine. And people come into our museum who know nothing about mining and have never seen a drag line, and they are just absolutely amazed at the size of this monster. When you look at the comparison between the little people and the little trucks standing next to this machine, and they always ask me, "Is that accurate?" I said, "Yes, it is. They have the correct same scale." And then we also have one of our good friends, Matt Wayan, made a 3D printed bucket for us, actually, right to scale, and we've been able to place in that bucket 2 HO scale buses. And that's, for demonstration purpose. We know they did that in the field. We actually have a picture of somebody backing a bus into that bucket. So that's kind of an eye catcher in our museum. We appreciate having that.
And which, even there, if we look at, William's little video, he's sitting right beside an HO scale one too, which I don't have any of my model trains on hand, but you see that thing is how size that is beside William, and my sizable model trains are give or take that long by that high. That even just shows how big this machine was.
Well, I like to tell people, because we do have numbers. We've got some publications that have numbers on them, and we know the machine was 151 feet wide in total, and with the boom down, it was 487 feet long. So that's, you could give some people some really accurate numbers by stating that, and that people are still amazed. We have a museum that has a building that's 47.5 feet wide. So when we talk about that, we can say this machine was 3 times the width of this building. And it's just like people roll their eyes and say, "I can't believe what I'm looking at." Yeah, there's Leo standing there next to the lift cylinder.
Yeah, which that's good. That's where I was gonna head towards next as well, to how this because we talk about the walking drag line that they walked, not exactly like we walked down the street, but they walked. They didn't.
Big Muskie was the only one that we built that had hydraulic propel. Every other drag line that we made had some type of a cam system, but the engineering at the time felt that they needed to go this route. And so it was a very unique machine, lots of hydraulics on there that had 48 hydraulic pumps to make this work. And each of those hydraulic pumps was capable of 180 gallons per minute of oil flow. Just a tremendous, tremendous amount of oil.
Yeah, Bill, before the show, we were talking a little bit about the walking chute. Why don't you go back and what you were telling me about that? Because this is also unique to this machine. It's not something that they did, across the board.
That's correct. That's a unique system, completely unique. It has 4 lift cylinders that actually lift the entire machine, and those are clearly shown there in Wheel's drawing. He's standing next to one of the vertical lift cylinders there in that graphic. And then you've got 4 push cylinders that work with that system. So the lift cylinders actually push down against the shoe, raise the machine, actually lift it off the tub. I think the tub is maybe dragging a little bit, but it lifts it off that 105-foot diameter tub. And then it slides the machine. 14 feet is what the step would be on that machine. So you got the lift cylinders lift it, and then the 4 push cylinders slide it. And then, of course, then you retract those lift cylinders, and then you're good to take a second step, or you can rotate the revolving frame and turn the machine if you'd like to at that point. So that's all hydraulically driven. So you got all of these large 48 pumps driven to generate all of this oil flow. It's a tremendous amount. You can imagine those lift cylinders, I believe, are 58 inches in diameter.
That's right.
Okay, and I know the push cylinders were 27. So, just add up, if you wanted to do a calculation and add up all of the volume of the oil, you could do that, with math. So it's just a tremendous amount of oil that's being moved every time you move that machine.
I'm not exactly good at math, so I'm going to go with a lot. That's what I'm going to go with.
Yeah. Yeah.
What size hydraulic lines would even be on that? I mean, that fascinates me. That's you think of a hydraulic cylinder, and that is huge.
I don't know the answer to that. Maybe Wheel does. I don't know.
They had steel pipes as 2,500 psi that those operated on.
Do you know the diameter of those pipes?
No, I actually don't, Gary, but I'm going to tell you just based on the pictures and stuff, 2 inches is that may be the small side of it. They may.
Well, I was going to guess that also. I was going to say somewhere around 2 or 2.5 inches in diameter.
Because it's a lot of, you had a lot of flow to go in there to lift that cylinder up. So yeah, I would agree with you.
Yeah, I mean, yeah, definitely. You think about how much, like you said, how much you're lifting, and
the heat that was generated when they did that, went through that cycle, those houses that were on this doesn't show it, but there was a house that sat above this. So where is it? Get it in here. Okay, that shows a house behind it there.
Okay.
There they are. These houses contain the pumps that he was talking about. I think each one, there was 16,000 gallons of hydraulic oil. And then these are vents because the tremendous amount of heat that was generated when you compress that oil to lift those shoes. And that part of it was a bit of a nightmare. I know whoever designed that probably had quite a headache to try to get that thing resolved. But it seemed to me they did have quite a bit of issues with the hydraulic oil on those.
And now when it takes a step, so when it pushes back, or like you said, it could go forward, did the shoes just kind of ride along the track then at the bottom of those hydraulic cylinders?
Yeah, that was the Rams. Let me see that. Let me find that. Can't find my way around my own drawings. These are the Rams that moved it
Right.
back. And I think I got, actually, we can look at the picture. Let me get this back down. There it is.
See, Bill, we got you moving your stuff all over the place now.
Yeah. Here is the 14, I think it's 14-foot stroke, 22-inch diameter ram. And that ball that we're talking about, it same thing down here, it slid in this rail system here. And then when you made your step, after it shoved the machine back, it would retract the shoe and then suck that back in there and move the entire system again.
Now, with that, like, because you think a lot of walking drag lines, we use a eccentric cam system to just move the shoes one way and walk it, which is pretty much off of just one joystick control. Was that the same way with this, or did you have more than one control to make this walk?
You would use the drag controller, if I remember. We're actually working on a display for that for the museum right now. So you would switch from the drag motion. There'd be a motion switch, and you would use one of the master switches to do that, I believe. So it would be working together simultaneously. You wouldn't use one shoe on one side and not use the other, I guess is what I'm trying to say.
Right.
They would be working together.
So it's basically like the other ones. It was just tied in, and they all moved together off the same control.
Yeah, you would have to have it set so that you're using equal motion on both sides of that machine, or you'd break something for sure.
Oh, yeah.
They're synchronized. And that's the same thing with the walking on the big drag lines today. The eccentrics on the outside, the cam, they're not connected. In the old days, it was connected by what they called a synchronizing shaft that went from one side of the machine to the other and kept those shoes together. But on the big machines today, they're synchronized through a mechanical, or today it's probably electronic.
Yeah, it's a Selson electronic device that maintains that the motor's simultaneous speed. So they have to move in unison.
And you can tell, I've been around long enough that when the synchronizing gets wrong on the shoes, especially like on a 2570 drag line, you got 12.5 million pounds, and the shoes would start out together, but then the other shoe on one side starts advancing ahead of the other side. And you can see what it does to the machine. It twists the machine right around. You can't do that. You'll break something pretty fast.
And on anything of this size, breaking anything is no small task or cheap task.
But you do raise a good question. I never really thought about it, but I'm curious as to, did the operator walk it, or because see, Muskie had 7 crew members, and there's no other machine that I know of in the mining industry that had 7 crew members. And I'm wondering if you actually walked the machines or controlled the walking mechanism from its own station.
Yes, you did.
So that's another thing that is separate from the regular walking drag lines. The operator sits in his cab, he's got a control. He turns the switches to switch over to his walking motors. Then he hits the button and it starts walking. Muskie, I guess he just set the brakes and told who the groundman, hey, let's start walking.
Huh. That's interesting because yeah, I always thought they just they controlled the walking shoes right from in the cab. I
Well,
didn't know that.
I think they did. I think they used the drag controller, and that was your motion switch.
But see, you don't have Muskie on most drag lines. The electric motors are switched because the generators that generate the power for the walking motors are used in a swing motor or a hoist motor or something. They switch it over. I know because I remember seeing that on the machine. And I don't know, Muskie, you had pumps. So you just started the pumps and somebody had to hit the switch to activate. And I don't know if it gained its power from another one of the, did you have a walking generator or was it using one of the other motions to get its power?
Well, I can tell you that it had separate motors to drive the pumps because it had 600 horsepower motors, and each 600 horsepower motor operated two pumps. That much I
Okay.
know. So that it was independent of the motors that ran the hoist and drag and swing. It had its own motors to do that. But I believe that those are run off the operator station with the operator sitting in the seat.
Okay, all right. That's, uh, yeah, I mean that makes sense. But yeah, I guess it's something to think about. It's the only, well, I guess would yeah, like you said, the only hydraulic driven walking one it was ever made. They all just used a big cam.
Right.
So,
And some of those cams are really big too.
yeah, yes, they are.
Yeah, they are.
We we had an 8750 cam in the shop, and that's a different machine than what we're talking about here, but it's a fairly big drag line. Machine that can weigh as much as 15 or 16 million pounds. And I physically weighed the cam after machining for an 8750, and that cam weighed 61,000 pounds
Whoa.
after machining.
Shoot.
That's 8750 is what replaced Muskie when they shut Muskie down. If I'm not mistaken, they had put an 8750 into operation back in the early 80s and it might have been late 70s. And it ended up, I think, finished mining the area.
Yeah, because it was what I have here was 1991 was when they parked it,
Right, Muskie.
and then when it yeah Muskie, that's correct. I don't have the information on the mine then, but it was retired in 91. So, which I'm not gonna try to hunt that down, but now we've been talking about motors off and on, which right next to this, Bill, you have a picture there of the house floor with the motors and the drums and everything on it. So maybe you could it was an electric. This was an all electric powered machine, not you didn't dump diesel fuel in it and
Oh,
start it. It was all plugged in.
it had a big trail cable going to it, and that trail cable, we actually have a piece of it in the Bucyrus Museum. That cable carried energy. The voltage was 13,800 volts, carrying energy to that machine. And just to give an example, that cable is somewhere around 5 inches in diameter. 1 foot of that cable weighs 27 pounds, if you can visualize that.
Whew.
And I was told that there was 1,500 feet of it running from the machine to the substation.
Wow, that's incredible. Now, I don't know if any of you know, maybe you don't know how much power it would use in a day or in an hour or whatever.
Well, I can tell you this, that if you added up all the horsepower on that machine, you had 52,500 horsepower of electrical motors on that machine. And I was told, and I don't know the efficacy of this, but at peak when it was digging, it was capable of using 18,000 kilowatts.
Wow.
Now
And
you got another situation there, Thomas, that also and Jerry might know a little more about this, but they called it cogeneration. Something that they came up with in the 70s and the 80s. And that is when that machine was swinging, when it had to brake, uh, they could pump, they would turn the motors into generators.
Yeah.
And that would slow the motors like a dynamic brake, but it would take the electricity and it would put it back into the power line. And I don't know if Muskie had that cogeneration. I know the captain did.
I don't think it did, but I don't know the answer to that. Only thing I really do know is it was AC power coming into it, and then there was five generators in the back of that machine, and that converted that energy to DC power because that was an old DC machine. Those were
Right.
DC motors, three phase. So that's a little limited information that I have
Yeah.
on it.
Yeah, that you made a good point, William, because I actually spent some time with a gentleman that lives near me here. He's since passed away, unfortunately, Jim Brennan, who worked for Marion Power, who built scale model Marion drag lines, and I actually learned a little bit of the electrical system from him, and it's a really unique way of how those work with
Was that
drawing or generating power.
Dragline World, Thomas?
That was Dragline World. Yes, I got to visit there. Got to run his
That
stuff.
guy, he was, oh my God, he's a legend.
Yeah, yeah. He unfortunately passed away. I think maybe 4 years ago or something like that. But I spent a day with him. He taught quite a bit about how the electrics worked on the Marion machines. Anyway.
He was genius, definitely
Yeah.
a genius.
Yeah. Now, and we can see it there in the picture you have, Bill. Most of those motors are running the drums for the drag and hoist, which we talked about that at the top of the show, how it would hoist with cables. How big were those hoist cables, for example? How big around were those?
The running ropes were 5 inches in diameter.
And was it
Largest
about the
made
same
at the time? That was the largest made at the time.
Yeah. And was it about the same for the drag as well, I presume?
They were the same, I believe. Yes.
How much cable would have been on these drums? Because just kind of give an idea of the size. How long would the cable have been on there? If anybody knows.
Well,
I'm going to look in a book here while you guys are talking. I may
Okay.
have on that.
I mean, look, I'll look at mine too. Because it was, I have to put my glasses on.
I mean, because I'll we'll look at what you guys are looking at, because you think about they had to, like we said earlier, hoist from 150 feet deep, maybe 200 feet deep.
100 is 185 feet to the depth for the digging.
Right.
I've
So
got something. I've got something here for you guys.
Okay.
Under the hoist machinery on one of our publications, and I don't know who published this, but it's a Bucyrus document. It says that the combined length of the four hoist ropes is 3,728 feet.
Roughly 1,250 feet a drum, because that's four. All of them was four.
It goes on to say that each hoist rope has a rated breaking strength of 2,160,000 pounds.
1,000 tons, over 1,000 tons. Yeah, that's mind blowing right there.
Oh my God! Could you imagine if one of those cables had snapped? That I've seen the little 3/8 inch winch cable snap on a winch on a pickup or whatever. You imagine a 5-inch cable snapping? My goodness.
I've only witnessed one time, and it was a hoist cable, but I was told that the core had collapsed in it. And it broke, but it didn't break where you would have thought it would have broke. It broke between the boom point and about midway down the boom. And when it broke, it shattered everything. There were shards of wire everywhere.
Wow, so it more or less exploded instead of just
It,
snapped.
it, it did, it literally. But as far as breaking, I never actually in all my years saw a hoist cable or a drag cable come apart during the operation. And really it shouldn't, because if your people are doing their job, and that means broken strands and broken wires, you should never be in that situation. It is dangerous.
Oh yeah, I mean that would cut you right in half in a heartbeat.
Yes,
Uh, um, and that's like I. It sounds redundant, but I keep trying to drive this home to people how big this machine was, and I think that's the more we go, the more you kind of get it just how big this was, and and in essence, with its size, dangerous because that they actually placed the cab on Muskie in a entirely different location. Most walking drag lines had a cab on either end of the house, so you could operate for best vision from the left to right. But Muskie, they actually put it center in between the boom. Just see Bill's looking for a picture there, but
Yeah. Yeah, and that's a good observation on your part to notice that.
I mean, I'm gonna presume that's probably another unique feature to this because I don't know that I've ever seen any others that had in between the boom, which the boom itself is almost a unique design.
absolutely.
I
You
can't
know,
think of I can't think of another machine offhand that had a cab in the center.
which interesting. The picture tonight we have right there, Bill. You can see the boom of Muskie looks more like the boom of a stripping shovel design as
Right.
opposed to what you see on most of the other walking drag lines in there, where it's almost two main booms tied together at the end, which I never noticed that before. But it's more, I
That's
don't know,
what it
maybe
is.
Jerry, you can answer that. Did they take more of the idea from the stripping shovel design for this as opposed to drag lines?
I really wouldn't know. Like you say, back in those days, I was just a young kid trying to make a living in the apprenticeship. When I was working on this stuff in the shop, I was just flabbergasted at what I was working on, and I did
Oh,
not know the design implications of any of it. And unfortunately, I never got a chance to see this machine in the field because I was a union employee working in the factory at that time, and I didn't get out in the field until many, many years later when I was in field service and other departments. So, some of you guys like Weo and other people who have been out and seen this machine, I got to say I'm a little jealous because I didn't get a chance to do that.
Yeah,
well,
you got to be really proud, Jerry. I would love to have said I designed that
yeah,
machine. I built that machine. That's really a monumental, uh, you know, task.
yeah. That kind of brings up a good point, Jerry. Let's approximately, if you could guess, there in the shop where you worked, just in the shop itself, how many employees would have been there at the time?
Well, it would be hard for me to know, but there were hundreds. There were hundreds of
So,
union employees, I believe, in our factory in South Milwaukee at that time. Possibly as many as 400 or 500. I really don't know.
yeah,
I can tell you that we had a big employment during those years. We were hiring people rapidly. It was very easy for a young man to get a job there. You remember Vietnam was going on at that time, and factories all over Milwaukee were at a high rate of production. Everybody was clamoring for help, and they were willing to take you and train you. They did that for me. They took me off the street and sent me to school and taught me what they wanted me to know because I was young and healthy, and that's what they wanted, someone who could work hard. And so it was really a golden opportunity for me. I kind of fell into it really. And the companies back then, all of them in the Milwaukee area were looking for help like that. So it was very common for young men to go and work in these factories. And I didn't have a clue when I started at Bucyrus-Erie what they made. I just walked in the door and said, "Hey, I need a job, and you need me, and let's go to work." And that's how.
Well, you guys, all of you there built one heck of a beautiful machine. It's a shame they could not have saved it
I know, isn't it?
before they
It's just,
scrapped it, but
it's too bad that it couldn't have been saved because it's a machine that will always be in history. They'll never make another machine like this again.
Now,
So it's
no.
always going to be the biggest drag line ever built.
Yeah, and you know, I was looking here too while we were talking, looking because I wanted to ask how much dirt it moved in its life, but I didn't figure anybody would know that. But I actually looked it up. It actually, in its 22 years of service, 608 million cubic yards of overburden, which is
that's a lot. Eh,
approximately 20 million tons of dirt that it moved.
I think, and I've heard this said, and I don't have the numbers in front of me, but I believe that's somewhere around twice as much as all the dirt that was moved to dig the Panama Canal.
Wow. Wow. I don't know. I've heard that, but that's just again. You just how do you wrap your head around that? That's a heck of a big swimming pool to dig.
Yes, it is.
Um, which I before we wrapped up because I have a feeling we could probably sit here and talk for the next 3 days probably nonstop if
I
we
know
would
we
get
I know
going.
you and I could sit in the conference room at the Bucyrus Museum and sit there all afternoon and talk. I know we could do that easily.
So there's one final thing we'll kind of talk about here before we get go. The bucket. You can still go see the bucket. It's in oh my goodness, I am breaking on the town in Ohio it's in. Just a little town. But there's a miners memorial park that has one of Muskie's buckets there. And I even suggest anybody go see it because if you see the bucket, you could just try to imagine what it was hooked to. Because as you said before, you could park 2 buses inside of it, full size Greyhound buses inside of that bucket. And it's let's see, I looked up here.
Connellsville,
That's it.
Connellsville.
Which I should know that because I don't live that far from a McConnellsburg here in Pennsylvania. I should actually know that. But
But and I'm so glad they at least got to keep that because that is, if you've ever been there, it's quite a piece of steel to see. It's unbelievable.
it is. It's a unique little park even because it sits right off the side of where Muskie worked for its 22 years of digging. It's right there just alongside of the old reclaimed mine sites now. And it it's just amazing how big it is. I don't know how to describe it. I don't know if any of you could describe it. I can't describe it. How massive this was.
Well, I don't know. I remember seeing one in the factory when I was working on it, and it couldn't be shipped obviously in one piece. I believe there were either 5 or 6 pieces to this thing when you shipped it out of the factory. I could tell you a little story on it. We had it. No, I didn't participate in this, but our welders had it had it assembled. What we do is we call them fitters, and they fit up the weldments. And it was standing in our biggest bay, which was our new erecting bay. Yeah, it was built in, I believe, 1962 or three. It was the highest and biggest bay we had, and they put a bucket together for Big Muskie in that bay, and it took up bigger part of that bay, and that bay was 75 feet wide, if I remember right. We had 100-ton overhead cranes in that bay, and the crane rails were 65 feet off the floor. So you can imagine the size of that bay. So they set that bucket together, pieced it together, and had dogs holding it. And somehow overnight, something happened, and that bucket fell apart. We
Oh,
came in the next day, and it was all laying in pieces on the floor. Fortunately, nobody was there, nobody got hurt. How it came apart, nobody really knows, except it probably just wasn't tacked well enough to hold it together.
Wow.
But that was an interesting story to see that bucket, once it was assembled in one day, and the next day it was all laying in pieces.
Wow. Now, how many, I guess train cars is probably how they would have shipped it down, I would presume. I imagine even that would have been a little too big for trucks, for tractor trailers.
I couldn't tell you for sure, but I would guess that would be rail shipments. I know that there was 580 some shipments altogether, because that's what we have on our list. And I think that somewhere between 300 and 400 of those were rail. All the big heavy welded sections, for example, would have been rail. Some of those pieces, I think, weighed as much as 300,000 pounds. Some of the rail or tub sections.
And that's insane, because it's well, you see the big rail cars going down the rail. Most of those are, I believe, 200 some thousand pounds when they're loaded. So you had heavier than a rail car, a loaded rail car.
Well, I think we had special like JTTXs or whatever they were, but we had very special flat cars. Some of the other stuff probably shipped in gondolas, because we used to do a lot of that. The machinery possibly, but anyway, I know that a lot of it went rail, because I remember being there and I remember watching people load these heavy pieces onto rail cars. And I can also tell you that I know we had inch and a quarter link chain on our high bay cranes in the assembly bay. And one of the pieces that we were loading one day broke that chain. You want to see some chain fly and go in just at high velocity and fly all the way up into the ceiling and all over the crane rails. That was really a scary thing to see. And that piece, whatever it was for, I'm not sure what part of the machine it was actually over a flat car when the chains broke, and it put that car right down to the tracks. I mean, it broke the bed of that car and pushed it right down through the trucks. And that car was smashed.
Jeez.
Yeah.
That's...
So fortunately, nobody was under it or got hit by a piece of link flying off that chain. But that was a scary thing.
Yeah, I don't want to see anything like that. I'm good without seeing anything like that. Well, I guess before we log off, do you have either one of you have anything that you can think of you want to share yet about it?
Well, I want to say one little thing here. We started this Wheel talked about us old guys as being his heroes. He doesn't realize that he's our hero, a guy that can make drawings like this and is dedicated to this type of machinery. Honestly, we really appreciate what he's done for our museum, and we really appreciate knowing him. So he should not take a backseat to us, because he's a hero to us.
What an honor. Thank you, Jerry. I appreciate it. I really do. But ever since I saw my first machine, I always wanted to meet the guys that built them. And you're one of the legends, buddy. You are.
Well, thank you, but you're one of our legends too.
Oh my goodness. So gentlemen, I thank you for joining me to talk about this. It's been fun. The time flew by.
Yeah, it sure did. Yeah, it really did.
It is. It's fun. I'm going to tell you, Thomas, I really appreciate the opportunity, but you're right. We could talk all day.
we may do that backstage yet, but yes, thank you guys for joining me.